Okay, the next problem we are going to do is very similar. Couple differences are just the side lengths we're given here on the triangle and the fact that we're being asked for the sine of 2 theta instead of the cosine. So looking at my formulas, there's only one formula for the sine of 2 theta. It's 2 times the sine of theta times the cosine of theta. So that's what I'm going to do. So I need to find the sine of theta and the cosine of theta. So looking here at my triangle that I'm given, we're going to use right triangle trig, so SOHCAHTOA. Sine is opposite over hypotenuse. So here's the opposite side from theta. Here's the hypotenuse, so it's 4/5. Cosine is adjacent over hypotenuse, so that's 3/5. So the sine of 2 theta is 2 times the sine of theta times the cosine of theta. So that's going to be 2 times 4/5 times 3/5. And remember that 2 just means 2 over 1. And when we multiply fractions, we multiply numerators together and we multiply denominators together. And so on top we have 2 times 4 times 3, that's 24. And on the bottom we have 5 times 5. And voila, that is our answer. Sorry, I didn't mean to jar the camera. Put my hand down. There we go. Emphatic. That is my answer. Next one is a little bit different. Okay, so let me see where I wrote this one down. Given that the cosine of theta is 5/13 and that theta lies in quadrant 4, find sine of 2 theta, or sine of 2 theta. My emphasis is a little different there. Okay, so this is another one of those things where we used an orange highlighter last time, so I'll do it again. That part is telling me that I need to know this because I need to know where to draw my triangle. I'm going to draw a triangle. And on my triangle, I'm going to start with the terminal side, which basically means just a segment that comes out from 0, 0. And I have to figure out where to put that, and they told me where to put it. They told me to put it in quadrant 4. Remember that there are different ways they can tell you to do this. Other ways they could have told me to put it in quadrant 4. They could have said that the sine of theta is negative. That's a way of saying that. Sine of theta is less than 0 is the same thing as saying the sine of theta is negative. The reason that would tell me quadrant 4 is because I already know that the cosine is positive, and the one place where the cosine is positive and the sine is negative is positive, negative right here. Another way they could have told me the exact same information about where to draw my triangle is they could have said something like this, that theta is between 3 pi over 2 and 2 pi. Or if we were in degrees, between 270 degrees and 360. This is 3 pi over 2. This is 2 pi. So that's just another way of saying, hey, we're in the 4th quadrant. So if you know you're supposed to be in the 4th quadrant, you start out by drawing a stick, a segment that goes out into the 4th quadrant. And then from the end of that segment, you go back to the x-axis, and there is your right triangle. Now I'm going to fill in the information they gave me about theta. And they told me that theta, cosine of theta, is positive 5/13. Well, cosine, remember SOHCAHTOA, cosine is the adjacent over the hypotenuse. So that means my adjacent side, here's what theta is 5. Theta is actually over here, but this is where we're doing it from. 5 over the hypotenuse is 13. Okay, so now I just need to figure out what the other side is for this triangle. And I'm going to use Pythagorean theorem. 5 squared plus we don't know what squared equals 13 squared. That's 25 plus missing side squared equals 169. Missing side squared is 144 then. This is 12. But the fact that we're in the 4th quadrant matters. That's actually a negative 12. Remember we said this is where cosine is positive and sine is negative. Okay, and sorry, I'm having trouble with this because I drew this picture a little janky. So I'm having trouble deciding whether I want to do that or that. So that means for my theta, the cosine of theta, we already knew was 5/13. The sine of theta is going to be negative 12/13. And we can use either or both of those. No, I'm sorry, I was thinking of cosine of 2 theta. We're actually looking for sine of 2 theta, so we do need both of those. If it was cosine of 2 theta, that was what I was thinking about and saying, well, we could use either one or both of them. But sine of 2 theta requires both. So sine of 2 theta is 2 times the sine of theta times the cosine of theta. So that's going to be 2 times the sine of theta times the cosine of theta. And I'm going to multiply, this is 2 over 1, remember, so 2 times negative 12 times 5, that's going to be negative 120. And in the denominator, I get 13 times 13, which is 169, and there is my answer. All right, so I'm actually putting this together with another video. Hopefully, I was doing a video and ran out of disk space on my laptop, much to my surprise. So hopefully I'm going to be putting these two problems with another problem. So we'll stop here, and then I'm going to do a separate video with 3 more problems of double angle formula, or actually it's 4 more problems that are double angle formula related. So I'll see you there. Thanks for watching.